Introduction to the polynomial function. So what is a polynomial? Poly means many, nomials means nomial. So polynomial means a nomial with many nomials. So polynomial functions have graphs that are smooth and curvy, that is there are no pointy bits. There is nothing like this, no pointy bits. They are continuous, there is no breaks or gaps or holes. They go on forever, they have arrows on the ends. Okay. So what are the common polynomial functions? This is a constant function, so you can see that it has arrow on the head, it goes on forever. This is a linear function. Linear means 1 with the degree 1. This is a linear function which is a graph with the arrows on the head. Quadratic functions with a degree 2. Cubic functions with a degree 3. Quartic functions with a degree 4. And quintic functions with a degree 5. So let's work on the degree of polynomial. Degree of a polynomial function is equal to the highest power exponent on x in the equation. For example, every quadratic function is degree 2. We know that quadratic function is a function of degree 2. What is the degree? The highest power in any polynomial is known as degree. And quadratic function has highest power 2. So it's a function of degree 2. The degree of the polynomial tells you the maximum number of x-intercepts the polynomial could have. Degree of the polynomial means the function has maximum x-intercepts, or the graph is intersecting the x-axis at the maximum points. Therefore, any polynomial of degree n has n roots, but these roots may not always be real. So if we have a polynomial equation of y is equal to k, so we have x to the power 0 over here. So this is the type of the function is constant. The degree of this function is 0 and x-intercepts in this would be 0. Now here the power of x is 1. So type of the function would be linear. Degree of the function would be 1 and the maximum number of x-intercepts would be 1. Okay, the degree of the function is 2. It is quadratic and the maximum number of x-intercepts would be 2. Degree of the function is 3. It is called cubic and maximum number of x-intercepts would be 3. Degree of the function is 4. It is called quintic. Quartic. Degree is 4 and x-intercepts are 4. And the next would be quintic or heptic or octic and furthermore. So you can see that in the constant, the x, this is the graph of a constant function. So is it intersecting with the x-axis? No. There are no points at which it intersects with the x-axis. So the maximum number of x-intercepts are 0. It is a linear function. So linear function is intersecting with the x-axis at only one point. So quadratic function is intersecting with the x-axis at 2 points. Quintic function, so it's 2. So quintic is intersecting with the x-axis as 1, 2, 3 points. So it has x-intercepts 3. Quartic function is intersecting 1, 2, 3, 4 points. So it has x-intercepts 4. So what are the x-intercepts? The number of points at which the function intersect with the x-axis. It is called the degree of the function or the x-intercepts or the roots of the function. Determine which graphs below represents polynomials. If the graph is a polynomial, determine the possible degree of the function. If not a polynomial, give a reason why. First of all, we would like to know that if this is a polynomial or not. Yes, because polynomials never end. So it is never going to end from here, never going to end from here. So yes, it is a polynomial. Then what will be the degree? 1, 2, 3, 4, 5, 6. Degree is 6. So it is not going to end from here, but it is ending from here, so it's not a polynomial. This is not ending from both sides, so yes, this is a polynomial. And the degree is 1, it means it's linear polynomial. Okay, it has a pointy bit. If we have pointy bit, it's not a polynomial. Okay, it's never ending. Yes, it's a polynomial. And 1, 2, 3, 4, 5 of degree 5. And this is ending over here and over here, so it's not a polynomial. Okay, the equation of a polynomial function can be a monomial. If it has one term, it is called monomial. Mono means one. If it has two terms, bi means two, it's called binomial. If it has three terms, tri means three, it is called trinomial. Has exponents or powers of x that are whole numbers. Exponents or the powers on the x will always be the whole numbers. It cannot be fractions or the negative numbers. For example, we cannot have x to the power -2, or we cannot have square root of x in the polynomial. Polynomial always have whole numbers as the power of x. It does not have fractions or the negative numbers. It has coefficients that are the real numbers, integers, fractions, or irrational numbers. So determine which equation below represents polynomials and which do not. If it's polynomials, identify what type of polynomial function is it, monomial or binomial. If it is not, state why. So we have f of x. First of all, we need to determine if the equation below represents a polynomial or not. So for the polynomial, all the powers of x should be the whole numbers. This is not a whole number, so it's not a polynomial. So these all the powers of the x are polynomials, and x into x would be x square. So it's a polynomial with degree 2, quadratic or binomial. Okay, it is with 1/2, so not a polynomial. It has the fractions, so not the polynomial. So it is a polynomial with degree 3, which means cubic. Consider the graph f of x below. State the degree of the polynomial. Degree of the polynomial is 1, 2, 3. Domain -infinity to +infinity. Range is -infinity to +infinity. X-intercepts are 3. Sorry, what are the x-intercepts? -1, 3 and 5. -1, 3 and 5. So it can be written as f of x can be written as x plus 1, x minus 3, x minus 5. And here the coefficient of x cube is +1, so it would be a would be 1. 1 is very important because it means the function is positive. It means increasing trend. If there is a positive number here, it means it is in the increasing way. So you can see here it is negative number. Negative means decreasing. So it is decreasing here. State the degree of g of x. So 1, 2, 3. X-intercepts -2, 1, 3. Here I will put -1 because here it is negative, which means decreasing trend. Describe how the graph of a cubic function with a positive leading coefficient is different from a cubic function with a negative leading coefficient. So cubic with positive leading coefficient means a. A represents leading coefficient, means like this, increasing trend. And negative leading coefficient, which means like this, decreasing trend. Consider the graph of h of x. State the degree of the polynomial. 1, 2, 3, 4. Domain, range, x-intercepts What do you think would happen if a is equal to -1? So here a is +1, so a is -1 reflect over x-axis. And behavior of polynomial functions. The way a function f of x behaves for very large values of x or very small values of x is called end behavior. To determine the end behavior of a polynomial function, we looked at the far left x values and far right x values. So if y is equal to f of x, x gets more negative, f of x get more negative. Here x is getting more negative on this side, f of x is getting more negative on this side. X is getting more positive on this side, f of x is getting more positive on this side. So state the possible degree which polynomial and then describe its end behavior. So the degree would be 1, 2. The possible degree of each polynomial and then describe one, two. Okay, so as x is going towards the this is the x going towards positive side, x approaches to positive infinity, f of x is also going towards positive infinity. As x is approaching to the negative infinity, f of x is again approaches towards positive infinity. So it's 1, 2. X approaches towards positive infinity, f of x approaches towards negative infinity. X approaches to negative infinity, f of x approaches to positive infinity. X approaches to positive infinity, g of x approaches to negative infinity over here. X approaches to negative infinity, g of x approaches to negative infinity. X approaches to positive infinity, k of x approaches to positive infinity. X approaches to negative infinity, k of x approaches to, here x is going towards the negative infinity, so kx is going towards negative infinity. Describe the end behavior of the function f of x is equal to 3x to the 7 plus 5x 4 minus 7. So the degree of this function is 7, which is the highest power. Write an equation in intercept form for each of the following polynomials. -3, 0, 4, x plus 3, x plus 0, x minus 0, x minus 4, which is equal to p of x. minus 5 minus 1 2 x plus 5 x plus 1 x minus 2 minus 2 minus 1 1 2 x plus 2 x plus 1 x minus 1. Here it would be x plus 1 x x minus 3 x minus 5. Based on your observations from question number 1, select the correct words to make each statement true. If p of x is approaching towards the positive infinity and x is approaching towards the negative infinity, p of x is approaching towards the positive infinity and x towards the positive infinity, then the degree of the polynomial is p of x towards polynomial towards positive infinity and x towards the positive infinity, x towards negative infinity and p of x towards the positive infinity. This one, p of x towards positive infinity, x towards positive infinity, x negative and p of x positive. So we are talking about the option C. The degree of the polynomial is 1 2 3 4, that is even. And the leading coefficient is positive. If p of x is negative infinity and x is negative infinity, p of x is negative infinity, x is positive infinity, and degree of the polynomial, talking about the option D, degree of the polynomial is again even and leading coefficient is negative. Now p of x is positive infinity and x is negative infinity. This one, p of x is negative infinity and x is positive. Option B. The degree of the polynomial here is 3, that is odd, and the leading coefficient is negative. The last one is p of x is negative infinity when x is negative and positive when x is positive. The degree of the polynomial is 3, that is odd, and the leading coefficient is positive. So what we get, we get to know that if it is behaving positive, negative, positive, positive, it's even and positive, even in negative, odd in negative, odd in positive. Consider the graph of p of x. State the degree of the p of x 1 2 3 4 5. Sign of the leading coefficient, so increasing trend means positive. Which could be the graph of the 4th degree polynomial with leading coefficient negative 3. So 4th degree polynomial, it's 1 2 3 1 2 3 1 2 3 4. So 4th degree polynomial can be it is 3 degree, it is 3 degree, so it is 4th degree and it is 4th degree, and negative 3 means opens down. So this is the answer. Which of the following polynomials can be written in the standard form? Circle all answers that apply. Okay, write an equation for a 5th degree polynomial with a leading coefficient 7 and a constant term -1. Write each polynomial function in Staten form and determine the degree, value of the leading coefficient and value of the constant term. Leading coefficient -1, degree is 4, and the constant is 0. Circle all the equations below that represents polynomial functions. So we know polynomial functions do not square index. This is not because -4. This is not a polynomial function because no polynomial should be there in the denominator, because no exponent should be there in the no 1/2 in the denominator. So this is again a polynomial function. Let me write the reasons here. No negative exponents allowed, no polynomials in denominator, one by two fractional polynomials are not allowed, variable exponents are not allowed. Select the correct equation for the polynomial degree, polynomial graph here. First of all, it is the polynomial for degree 1, 2, 3. So it's 0, 4 to -2.5. So it should be x -0, x -4, x plus 2.5. So x plus 4 are cancelled. We have two options, x -4 and x with 2x -5 or 2x plus 5. So it would be x plus 2.5, so it's 2x plus 5. So option C is the correct answer. Leading coefficient of 3. Okay, so leading coefficient here is degree 3. Degree here is, leading coefficient is 3 here, degree of the polynomial is 3, constant term here is plus 36, y-intercepted 0, 1. Okay, leading coefficients. This 3 is the leading coefficient. Here 5. So leading coefficient of 3 is A. Degree of 5 is B. Constant 36 is minus 36, this one. Y-intercept of 0, 1 means constant should be 1. Which of the following represents a trinomial with a leading coefficient of 3 and constant term of -5? Represents a trinomial. Tri means 3 nomials, 1 2 3 1 2 3 1 2. This is cancelled, 1 2 3. So leading coefficient of 3, leading coefficient 3, leading coefficient -5, leading coefficient 3, constant term of -5, constant term -5. So A is the right option. The correct equation for a polynomial with zeros at x is equal to 5 and x is equal to -1 and x is equal to -1/2 is x minus 5, x plus 1, x plus 1/2. So we should have x minus 5. So plus 5 is cancelled, plus 5 is cancelled, x minus 5 is the option, x plus 1, x plus 1/2. Determine the end behavior of the polynomial p of x minus 2x to the power 6 degree is equal to 6. P of x in descending order and answer the following questions. Okay, first of all we need to write the polynomial in the descending order. And what is the meaning of descending? Starting from the highest degree and moving towards the lowest one. Okay, so degree of the polynomial would be the highest degree, that is 3, value of the leading coefficient is -4, and the end behavior is the degree is odd degree and negative leading coefficient means decreasing trend. Multiplicity of a root in a polynomial function. Every root has multiplicity, which refers to the number of times that its associated factor appears in the polynomial. For example, the polynomial f of x is equal to x minus 5 whole square is x plus 3 has double root at x is equal to 5 and a single root at x is equal to -3. If a root has odd multiplicity, graph will cross the x-axis at the root. If the root has even multiplicity, graph will bounce off and not cross the x-axis at the root. For example, if it has 1 single root, so it is crossing the x-axis at the single root. If it is multiplicity of 2, double root, so it's crossing the x-axis like this in the double root. It is 3 roots, so it is 1 2 and 3. 4 roots, 1 2 3 and 4. So revisiting the end behavior of the polynomial functions is as end behavior, the way a function f of x behave for large value of x for very small values of x. To determine the end behavior of a polynomial function, we look to the far left values of the x-axis as x approaches to -infinity and the far right values of the x-axis as the x approaches to +infinity. The sign plus minus of the leading coefficient of the polynomial function will impact its behavior. So as x approaches to infinity, f of x approaches to +infinity, and x approaches to -infinity, x approaches to -infinity. It is called increasing trend. negative infinity and infinity. It is called decreasing trend. Okay, so graph of the polynomial function. Linear function has one real root. So quadratic function has degree 2. It has two single roots. For example, it has y is equal to 2x plus 2, one real root. So for example, it has y is equal to x plus 2, x minus 2. It has two single roots. Or it can has one real double root. X minus 2 whole square means one real double root. Two imaginary roots means there is no point on the x-axis. Quadratic function is an even degree function. Cubic is an odd degree function. It has three single roots. Three single roots means this means x plus 3, x minus 1, x minus 2. Three real roots, one single and one double means this one is double root, this is single root. Three real roots, one triple. One real root plus two imaginary roots means y is equal to x plus 2, x square plus 1. Quartic means again even degree. Four real roots. 1, 2, 3, 4. Four real, two single and one double like this. Two double. Four real roots, one quartic. Example. Okay. Two real single roots and two imaginary single roots. These are two real. One real double root, two imaginary single roots. Four imaginary roots. for imaginary roots. Sketch the graph g of x 1 by 2 x plus 4 x plus 1 x minus 2. So it would be x is equal to minus 4 minus 1 minus 2 minus 4, x is equal to negative 1, x is equal to plus 2. 1 by 2, sorry, we need to check that it's 1 by 2, so it's increasing trend positive. For y-intercept, we need to put x is equal to 0. So x is equal to minus 4 minus 1 plus 2, y is equal to minus 4, degree is equal to 3, and leading coefficient is positive, so increasing trend. Consider the polynomial function y is equal to 3x square, x plus 5 whole cube, x plus 2, x minus 3 whole square. List the roots of the p of x with their multiples. X square means double root at x is equal to 0. X plus 5 means triple root at x is equal to minus 5. Single root at x is equal to negative 2, and double root at x is equal to 3. So x is equal to 0, then minus 5, minus 2 and 3. Double root, triple root, single root, this is again double root, which is what is the degree of the polynomial. Sketch the graph of p of x and label x and y intercepts. Finding a value. There are infinite number of quartic functions that have a double root at x is equal to negative 2 and single root at x is equal to 1 and x is equal to 4. Three possibilities are shown. In general, the equation for such a function would be f of x is equal to a x plus 2 whole square x minus 1 x minus 4 where a is not equal to 0. So what makes each of these quartic functions unique? Each has a different a value. What is the a value of the quartic function on the right that passes to the point 3 minus 250? Write the equation in intercept form for the function graphed below if it passes through the point -1, -162. Write the equation in intercept form for the function graphed below as it passes through the point. So at this point it is triple root. At this point it's 1 and it's single root. So it can be written as if y is equal to a x plus 4 whole cube x minus 1. So y is -162 is equal to a minus 1 plus 4 whole cube. As they're saying to write the answer, final answer in the standard form, for we need to multiply it. Our cubic function p of x has a leading coefficient 1 in the root. It's -6, 1 and 3. Sketch the graph of p of x clearly, identifying the roots of y-intercept. So x would be -6, 1 and 3. Cubic function q of x has a leading coefficient of -1. The function has a single root at x is equal to 2 and double at x is equal to -3. Single at 2 and double at -3. Leading coefficient of -1, so it would be polynomial function has the equation this. Sketch the graph of r or x clearly and identify the roots of the y-intercepts. So y-intercept, put x is equal to 0, y is equal to 0. So it would be x is equal to 0 and y is equal to 0. X is equal to plus 2, 1, 2 and minus 3, minus 1, minus 3. Polynomial function has the equation t of x is equal to minus x minus 4 whole square and x plus 3 whole square. So negative means decreasing trend and negative means decreasing. Minus 4 means 1, 2, 3, 4. Write the equation in the intercept form for each of the following polynomials. So this is the decreasing trend, so it's going to be negative 1, x plus 5, x plus 3, x minus 2 and x minus 3. Match the cubic function below with the correct graph. Let's find the y-intercept first. So it would be by putting x is equal to 0, 1, minus 2, minus 4, which is 8. So once we get the y-intercept, it's very easy to calculate because the y value of 8 a is equal to 16 is in figure A. Here it is 8, 4, here it is 4 in C, and in D it is negative. Sketch the accurate graph of f of x. Clearly identify the roots and y-intercept. So y would be 0 and x would be 0. So double root from here. X plus 4, 1, 2, 3, 4, and x plus 3. Sketch an accurate graph. So it's the negative means going in the negative trend from like this, minus 3 plus 2 minus 1 plus negative 3 and negative 1 has single roots, so it would be single roots. 2 has triple root. A cubic function has roots at minus 2, minus 3 and 1 and passes to the point 240. cubic function has double root at 0, single root at -2 and f of 3 at 90. A quartic function has a triple root at x is equal to -3. we now know that some polynomials in general form can be factored and written in intercept form. So what will be the degree? For example, state the graph f of x. Let's say the following: -1 +2 +4. So -1 has root 2 multiplicity, and finding y is equal to 1 -2 +8. So degree of this equation is 1, 2, 3, 4. Y-intercept is 8, and behavior is as x is going towards -infinity, f of x is going to positive infinity, x is going to positive infinity, f of x is going to single root. What are the possible equation for p of x in the intercept form? Use long division to divide 5773 by 21. Okay, so 21 in taking only first two numbers. 21 2 times is 42. So it's 15. Putting 7 down, it's 157. 21 7 times 147. 103. 21 4 times is 21 a factor of 5773? Why or why not? 21 is not a factor of 5773 since remainder is not 0. The first step is to arrange this in descending order. So x is going to go with x square. So with x square it's going to be x square minus x. We will get 2x square minus 4x minus 6. X with 2x plus 2x, it will come 2x square minus 2x. Minus 2x minus 6. Minus 2 minus 2x plus 2 minus 8. So the quotient is 2x into x square will give us 2x cube minus 5x square. polynomial p of x is divided by x minus a, the remainder can be found by calculating p of a. P of a is equal to 0, then x is equal to a is the factor of the polynomial p of x, and x is equal to a is the root of p of x. So find the remainder when f of x is divided by x plus 2. If you get 0, then x plus 2 is a factor. When a polynomial f of x is divided by x plus 5, the remainder is minus 2. Circle the statements below. Date best describes the solution. We factor polynomials. In the past, we factored quadratic functions to find the roots so that we could graph the functions or solve application problems algebraically. Common factors. So solve each of the equation by factoring and listing the x-intercepts. First taking x common. Okay, so x is equal to 2 is a root. It means x minus 2 will be a factor. It means when p of x would be divided by x minus 2, remainder would be 0. And it means if we will put 2 in the polynomial, answer would be 0. It means p of x will meet the x-axis at 2, 0. So there are 5 stars. X is equal to 2, which means if x is equal to 2 is a root of the polynomial, it means x minus 2 is a factor of that polynomial. When polynomial is divided by x minus 2, the remainder would be 0. When we will put 2 in the polynomial, the answer would be 0, and p of x will meet the x-axis at 2, 0. Consider the polynomial using long division fully factorized g of x given that g minus 3 is equal to 0. An open box can be made by cutting squares out from the coordinates in 9 inches into 12 inches rectangular sheet of cardboard and folding up the sides. If an open box, if each square removed from the rectangle with very thick, cycling paint for the volume on the resulting box with respect to the x, so volume would be equal to